Hello and welcome to our new webinar, the new KNX weather devices, the weather unit, the weather station and also the analog input. Yeah, my name is Thorsten Reibel. I'm sitting here together with Jürgen Schilder. We will conduct this webinar together. So I will start with an introduction into the applications of using all these weather components. I will go into the components, of course. And Jürgen will show you later on the integration of the weather unit into the IBAS tool, our famous service tool. So you will see all the functions together with the IBAS tool. Yeah, if you want, you can send us some questions in the chat room on the lower right side. We try to answer these questions latest at the end of the webinar. If not possible, we will send our feedback email, also an answer to your questions. And this feedback email also contains, of course, a recorded video file and also the presentation of our webinar. Good, so let's start. New weather unit, weather station and analog input. So first of all, what are the applications together with these KNX weather devices? We have different sensors normally connected to such a solution. Starting with the outside brightness, you see there's the first applications. So if you measure the outside brightness, you can control also, of course, depending on on the outside brightness, the lighting inside your building. For example, in an office room, you switch off the light depending on outside brightness, or you dim down to a certain level if you need something like this. Or if it's dawning, you would like to switch on the light in the parking area. All these things can be done together with detection of outside brightness. Of course, with a brightness sensor, you can control also any shutter blind solutions, any awnings or curtains can be operated. So depending on a brightness limit, you would like to operate your shutter blinds. You can run into a fixed position, but also possible with our shutter control unit to have a dynamic situation, means depending on the sun position, the blinds will be run into defined positions and also the lamellas will be positioned. All these things are possible, and for this application you need the measurement of the outside brightness. So what else is possible? Detection of the outside temperature is a typical sensor in the solution. What can you do with this? You can display the outside temperature, for example, on a display in your building, but also possible to create a kind of so-called summer compensation. Means the following: depending on the outside temperature, you adjust the set point of your cooling system. The target is to have not such a big gap between the outside temperature and the indoor temperature in case of high outside temperature. So you increase the set point depending on outside temperature. We call it summer compensation, to save energy and to have not such a big gap between both temperatures. Or here another solution for shading system depending on outside temperature. If the temperature is bigger than 22 degrees and the sun is shining, then you run the blinds down, for example. Or frost protection, if you have any frost sensitive components outside, for example an awning, any textile which is not able to handle frost temperature or low temperature, or any water application like fountains you would like to switch off in case of frost, can be done as well, depending on outside temperature. We can normally also detect rain, another sensor. Detecting rain means, first of all, of course, again, you can show it inside your building, whether it's raining or not. Or, a more important application, you can close windows, especially roof windows, if it's raining. It's clear if it's raining you should close this, otherwise you harm your building. Or again, any water sensitive hangings like an awning shall be controlled, shall be put into a safe position in case of rain, for example. Wind detection is a further sensor in such a solution. Also the wind speed, for example, could be shown inside the building, but the standard application is to run any blinds, awnings or also windows in a safe position in case of strong wind. You can imagine if you have any blinds, outdoor blinds, and strong wind appears, that can also destroy your blinds, and you should protect this. And you do it together with the threshold and the wind sensor. Yeah, very often in such a KNX weather solution, we have different sensors integrated. We will see it later on with the weather unit, where it's standard. So it's possible for us to combine different sensor data, to compare something, to create an end solution, for example, a logic, and then to take action if something happens. For example, you can combine brightness and temperature, so outside brightness, outside temperature. Sun is shining and high temperature outside, typical summer situation. Run the blinds down, for example. It could be a solution. Or vice versa, sun is shining and low temperature outside, winter mode. You move up the blinds, for example, to heat up the rooms free of charge. Nobody's in the room maybe, and you can do it this way. Or here another solution from a real project. We measure the outside temperature and rain, the situation, rain yes or no, we know, and also the humidity of the air. And I compared the following way. If the outside temperature is below 2 degrees and it's raining or it's high humidity outside, then some stairs at the entrance of a building will be heated up to have no slippery, let me say, surface. Solution we have here in our Heidelberg hotel next to our factory, where KNX is installed, so a quite nice solution. Inside the weather unit, I will talk about this in the next slides. So we have also an internal, let me say, comparison of two brightness values. We have so-called left and right brightness, west, east, for example. And we can also compare these two brightnesses. So in this example, if the threshold brightness of the west side maybe has been reached, and this brightness is greater than the brightness from the other side, from the east side, then we run our blinds. This guarantees us that the sun is shining from the west and no reflection from an opposite glass facade maybe fools our system. That can happen sometimes. So it's an internal parameter we can adjust here in the weather unit, for example. What else do we have as examples for combining different sensor data? Brightness, again from the weather sensor, time, and presence. So is somebody in the room? Via our presence detectors. So we can also incorporate external status information, like is somebody in the room, in our complete logic inside these devices. For example, here again, this classical logic, sun is shining, it's working time in an office, and it's summer mode, and people or persons are inside the room, then we run the blinds down to keep the sun outside. The same in the winter season, so nobody's in the room, but sun is shining. Then you would move up the blinds again to heat up the room. So it's also dependent on presence here. You would like to integrate in our complete solution. Or here, wind and rain. If wind is above a certain value and it's raining, you would like to close all electrical windows if available. Or here we compare outside temperature measured with our weather station or weather unit and the room temperature. And then we create a kind of natural ventilation, means we compare both temperatures, and if it's colder outside in the summer, in the morning for example, we open automatically the windows to cool down the building free of charge with cold air coming from outside. So you see a lot of standard application, but also some specialties are possible if you have such weather sensors in your KNX project integrated. This was related to weather unit, weather station, but a further new device, I will talk about this at the end, is our new analog input as a DIN-rail device. You see it here. And an analog input, of course, is able to measure any analog values from any kind of sensor, not only weather related also, but mainly other sensors like pressure measurement, temperature measurement as well, or flow quantity you need sometimes, humidity, any level management, measurement of a tank, for example. All these things can be monitored and evaluated, and any action can be taken if something happens. So, for example, you would like to monitor the temperature of a cable tray where a lot of cables are installed. So you need a temperature sensor connected to analog input. or you would like to monitor a filling level of a tank. Measurement of humidity in a server room, which might be very important, for example. Or in an HVAC system, you would like to measure the airflow, again the humidity in the air duct, or also the temperature, possible with such a solution as well. Or here an application from a more residential project, you would like to have garden irrigation automatically, so you measure the humidity of the soil and automatically the irrigation will start if necessary. And maybe other special solutions are possible with an analog input. Yeah, let's come now to the devices. I would like to start with the weather unit, a new weather unit, WZIS 1312 now called, together with a new, complete new sensor, weather sensor WES/A 3.1. And you see, it's completely different from our former weather sensors, but I will come to this in some more details. So if you see the complete solution, it's a bit described here at the beginning. We have our weather unit as a KNX device, connected our new weather sensor with 4 wires with different data, you will see later on. Of course, this device is connected to KNX, and we have here a new feature. We have an additional input for PT1000 temperature sensors. So in this weather sensor is already a temperature sensor integrated, but we have the option to add an additional one. I'll come to this later on. Yeah, and very important, most of our new devices will be supported by our IBAS tool, and of course also this weather unit. So you have a lot of option to check the situation of your weather sensor, to simulate some situations, some functions. You will see later on, Jürgen will demonstrate this to you. Furthermore, if necessary, an update of the firmware of this weather sensor is possible if necessary. Very easy way, so also supported by this IBAS tool. Yeah, which kind of data we can measure and evaluate together with this solution, which consists of the weather unit and weather sensor. We have the standard values available, which is wind first of all. Measurement up to 50 meters per second is possible. Is it raining? Yes or no? It's only a 1-bit information. Brightness, outside brightness can be measured in 3 directions, up to 100,000 lux. Twilight measurements in a lower level can be carried out here. Out of this we can evaluate, do we have day or night situation? Very simple. There's a fixed threshold, 10 lux, so if you have a brightness value over 10 lux, then it's day, otherwise night mode. Outside temperature from -30 up to 60 degrees Celsius. And as before, we have also GPS sensor integrated here in the sensor, which gives you date and time, sent also on the KNX bus, and additionally latitude and longitude. But this is only visible in the IBAS tool, so not sent on the KNX bus as a communication object. So that's in principle the standard sensors we have integrated here. Yeah, and the KNX part of the solution, our DIN-rail component here. You connect your KNX bus, of course. Allows you to connect, of course, a weather sensor with 4 wires as before, 2 for power supply and 2 for communication. And here on the upper right side, the PT1000 temperature sensor. I come to this a bit later. We need power supply here, and of course, as mentioned, we can work together with the IBAS tool. The connection between our weather unit and the weather sensor is not KNX, of course. The weather sensor is not a KNX device, so we have no KNX bus cable outside, and we prefer such a solution because due to security reasons nobody can get access to KNX from outside. It's different from some solutions from competitors. Yeah, and this package or this solution I will explain a bit more detailed in the next slides, is in principle made for residential and small commercial projects. That is our focus here. There's a big market, of course, especially for this powerful solution, sun tracking with a shutter control unit. We really recommend to use our weather station, the new one with any external sensors, or our brightness sensor HSS 421, which is also let me say, very powerful regarding brightness detection and very precise sensor. So this is for this application preferred. So keep this in mind. So this is our focus here in this product, residential and small commercial projects. Yeah, what is available? Just a short overview of the application. I come to some more details later on. First of all, and you will see it also in one of the next slides, we can use the weather unit, the new one, also to connect our old sensors. It's possible. We can adjust this in the parameters, but you will see later on in a picture how it looks like. Yeah. Of course, all measured values will be represented in the right data type, depending what you are measuring, meter per second, lux or degrees Celsius. We can program thresholds for each of our measured values. We have logical functions integrated. We have the option to store measured values in 4 memories, and each up to 24 values each. Yeah. So it was also available before, but it's a special ABB feature in our weather unit. If you exceed any thresholds, you can program the time, the duration, where the value should underflow or overshoot the threshold, and then you take some action, not before. And just to avoid any fast operation of any blinds or light switching off in case of sun or less sun. So a certain time the situation have to be active and then action will be taken. Yeah, and we can also adjust an offset for our temperature sensor. Remember, it's an outdoor sensor or weather sensor installed normally maybe on the roof of the building, so not on the earth directly. And maybe the temperature measurement is not that precise for the temperature on the ground, so we can change it a bit, adapt it a bit by such an offset here. Yeah, connection is very simple. KNX bus connection, power we need. Possible now also to connect our the voltage like all the other new devices, wide voltage input range from 85 to 265 volt AC. So that's more or less valid for all our components nowadays. With 4 wires I connect my weather sensor, and with 2 wires, if you need, an additional PT1000 temperature sensor. Furthermore, we have 2 LEDs, one indicating component is running, LED on means power is existing, and an error LED here, communication error, indicating that there is a wrong or not existing communication between the weather sensor itself and the weather unit. Yeah? Gives you also a fast optical information here. Yeah, let's come to some details in the application together with some screenshots of the ETS application. Date and time is available thanks to our integrated GPS sensor. And to remember also latitude and longitude if you use the IBUS tool. Date and time can be sent on the bus as a real information to synchronize any other devices. And everything related to this date and time functionality can be adjusted here, including some further adjustments not visible, which has to do with daylight saving time or the difference of your local time to the UTC time and so on. So you can be adjusted here. Yeah, value memories I mentioned already. Allows us to store on 4 channels up to 24 values. And how can you do it? You can do it cyclically. For example, you would like to store the night temperature. So every hour you read in the value and store it inside this memory, and up to 24 values are possible. It's possible to store the current value at that time where you would like to store it, or the minimum or maximum value or the mean value of the period back to the last storage. So for example, 1 hour is your cycle, and then it will take maybe the mean value of the last hour and will store it here. Yeah. So it's a simple but nice option to read out some historical data out of the weather unit. For example, here the night temperature you would like to observe, and what you need is nothing else but a display. And on the next page we try to show you how it works in principle together with 5 communication objects. to read out these historical values. So first of all, we have 4 memories. With this first communication object, 1 byte, you select the memory you would like to read out, which is 1, 2, 3, or 4 only. You send any of these values. Then, on another next communication object, the number of stored values will be sent back. You see in this case here on our smartphone, 24 values were stored. And then you can ask for the values by sending a 1-bit telegram, value 1 for reading the next value, value 0 for reading the previous values, symbolized here by these arrows. And then you see on the next 2 communication objects the time where it was stored and the value itself. In this case, at 7 o'clock p.m., there was 2.5 degrees outside. And then you can jump to the next values and have a look what happened in the past. Thresholds for each of these dynamic values. We have thresholds available where you can program limits, an upper and a lower limit to have a classical hysteresis. And if you overshoot or undershoot these thresholds, then you can send a command on the bus, a 1-bit telegram or 1-byte telegram. And again, this duration for over and undershooting can be adjusted as well to avoid any fast operation you don't want to have. And on the next slides you can see how it works in principle. The threshold principle with upper and lower limit. So prerequisite is that you overshoot the upper limit, and then an on or off telegram will be sent depending on your parameterization. So we have no duration for underflow and overrange here, overshooting. Direct action if you reach the limit, but you have to undershoot the lower limit, otherwise nothing will happen. So this is a hysteresis principle here. So nothing happens if you fall below the upper limit, only if you fall below the lower limit. And together with a minimum duration for overshooting, you see, here we reach the limit, the upper limit, but now the time is running, maybe 5 seconds or 1 minute, and all the time this overshooting is still active or existing. Then the command will be sent out to take some action. Switching off a light, running down the shutters, whatever you want. Logical functions integrated. We have 4 logical functions, AND and OR, with each 4 inputs. And these inputs can be internal thresholds of the internal sensors. For example, here, brightness sensor in the center, threshold 1 exceeded, and temperature, threshold 1 exceeded, and also external 1-bit signals can be incorporated, for example from the presence detector or from a humidity sensor. We do not have directly here. So quite powerful logic is possible here. Furthermore, we have here the option to monitor the wind sensor, which can be a very important part of the total solution. If you have a blind system behind, which can be destroyed in case of strong wind, you have to or should monitor the wind sensor. And how is it possible? 2 options you have, or 2 communication objects. Wind sensor disrupted and wind sensor 40. What does it mean? We can adjust a monitoring time for each of these communication object. Wind sensor disrupted up to 24 hours. And if the sensor does not see any change of wind during this period, which should be very unusual, normally any wind will come within 24 hours, then value 1 will be sent on this communication object, maybe to inform you that something might be wrong with the wind sensor. But at least you have to check. The next level is the same principle, but now we can evaluate the wind sensor up to 96 hours. Again, we expect, or we have a look, is there any change in wind speed? If not, again, on the other communication object, value 1 will be sent. And additionally, the maximum wind speed will be set to 50 meters per second, which is the maximum. And if you have any blind system behind with limits for wind, of course the blind will go up automatically. It will run in the safe position, so at least nothing will happen if really the sensor is not working. So it gives you a good chance to monitor together with these 2 communication objects the wind sensor. Then we have some additional communication objects. I don't want to go in all the details. You see here the screenshot. For example, the status byte measurement is a 1 byte communication object. And each of these bits in the 1 byte object gives you information, for example, about missing GPS signal or sensor signal, or component is still in calibration mode. So it's a very complete, let me say, communication object with a lot of information. But we have also some further information. If the weather sensor completely is not working, we have a 1-bit communication object here, kind of collective message. Wind sensor is not working, or any communication error exists between the weather unit, weather sensor, can be also sent out as a command here. Also the brightness sensor itself will be monitored. So a lot of options to check the complete solution according to any malfunction. Let's have a look to the weather sensor itself. Here you see a nice picture. So really different from the former version. One topic or one solution is really different. The real wind sensor we have right now with a rotating part, which is different from the former solutions, where we had only an indirect measurement via a temperature sensor. So by strong wind, the sensor was cooled down, and this was, let me say, calculated to any wind, which was okay, but not that precise, especially in the lower values. But let's have a look to the sensor, some more details. So it consists of the component itself and a holder to mount this solution. We have 3 brightness sensors integrated: rain sensor, wind sensor, temperature sensor. So, and the holder itself on the next page. In principle, we have here the 4 connections, 2 connection terminals for the power, 24 volt, and 2 for the communication. And here the cable entries. We can mount it here with 2 screws, but I think the next slides are even better to understand how it's mounted, because we see real pictures. And this is a holder here. Again, communication, or here, this is communication, this is a power connection terminals, 2 screws, delivered with a package, including some washers to close this complete holder to the rear side to have IP44 protection. Very simple principle, but everything is delivered with this component, including screws, and also plugs are delivered. And what you do after you have installed the holder, you take your sensor itself and you pull it onto this holder, like this here, very simple, and then it's fixed. And automatically, you cannot see it here, there are some pins. These pins will connect automatically in these connection terminals, and everything is established. You don't have to connect anything anymore. If you have done this, you should tighten here the complete solution with a screw, so nobody can remove it anymore. And then you should align, of course, the sensor horizontally, so then it's measuring correctly. And it's possible here it's turnable here. As you can see here, this point allows you to move up and down the sensor a bit to adjust it. As already mentioned, we have 3 sensors integrated, 3 brightness sensors. Always a question, what is west and east and so on? We have done it the following way, that we say left and right. So if you look from the position of the mounting area on the right side, this is brightness sensor right, left, and of course here is center. The same you will find in the IBAS tool, so it's very easy to identify the sensors according to the position. One small or additional LED you will find on the sensor itself. You can see it here, it's a green LED. This green LED, don't get confused, shows at the beginning of the commissioning phase or give you some information about establishing voltage and communication and so on. Latest after 10 minutes it will go off. So any end user, any customer will not get confused by any blinking LED and will call you. It's only for the commissioning phase. Interesting. And then don't forget we have these additional connection for one PT1000 sensor integrated here, which is new. And this is a typical temperature sensor. We can use the standard PT1000 in 2 conductor technology, means only 2 wires necessary. Later on with the analog input and weather station I come to a 3 conductor technology, which is also possible. What is the target behind? To measure additionally temperature at another location than the weather sensor itself. Because the weather sensor is anywhere installed on top of the roof, but maybe you would like to measure the temperature at the north side of your building where there's no sun, and that might be different, and you can do it with this additional PT1000 sensor. So you see an example how it looks like, a very simple device, everywhere available, very precise. It's also available with an integrated box for outdoor installation. But keep in mind, it will not be an ABB product. We do not deliver this. You have to, or your customer has to buy it from the market. But at least we have the option to connect it here. And finally, I just mentioned that we can also combine, or we can use also our former sensors, 2.1 or 1.1 together with our new weather unit. It's possible. This is our new version now, but if you want, you can use it like this. So old sensors with new weather unit, but vice versa as well. And this might happen sometimes that you have to replace the weather sensor here, one of these, by the new one, which is more powerful, gives you some more options. And you don't want to replace additionally the weather unit itself. You don't have to. It's possible, it works together. In the application, you can select this. And the only thing you have to accept, no wind sensor monitoring is possible with this combination here. And no IBAS tool function, because this old weather unit is not able to handle this. If you replace the weather sensor 2.1, you don't have to change anything in the application. You download, no download necessary, so it's only replacement of the sensor with the same functions as before, but not the additional functions. That you have to accept. But I think it's a customer-friendly solution that you don't have to replace everything if necessary. Let's summarize the new features of this new weather unit and weather sensor. Wide input voltage range from 85 to 265 volt. New. IBAS tool integration, you will see later on, it's very nice, including firmware update of the firmware of the weather sensor if necessary. Additional PT1000 connection possible for temperature measurement. Some differences here in the hardware, like bigger screw terminals and let's say more valuable sensor, which is completely new, including this real wind sensor. Many people asked for this, so it's, let me say, a more powerful solution. We have a kind of calibration process running in the background if you energize the device at the beginning. The same for the other new devices here. The PT1000 measurement will be calibrated if it's connected only. That's an additional feature we have here. Also in the other devices, I come to this. That's weather unit, weather sensor. Let's come finally much shorter to the new weather station. We have also renovated this device. We had already before, but now it's called WZIS/S4112. And what we deliver is only the weather station, the KNX part. Weather sensors, conventional sensors with any analog value behind, we do not deliver. You see an example of a solution of a very powerful weather station with a lot of sensors here in our factory in Heidelberg, with a lot of different sensors. You see here the wind sensor, for example. Here might be a brightness sensor. Here is a wind direction measurement possible. So the market offers a lot of components, and this you have to buy, or your customer buy yourself, and you can connect it to our weather station. Then you have a complete solution. One supplier, for example, is a company Quivan.com. Have a look if you want. But there are many others on the market, but they have quite nice weather sensors if you're interested in. What else do we have in the component? It's very similar to the former device, some changes only. We have a 4-volt device means 4 analog values can be registered or processed, can be measured. Yeah? And which kind of sensors we can connect? First of all, the value, the measurement, the control value, any voltage dependent value like 1 to 10, 0 to 10 volt, 0 to 1 volt and so on, or current related 0 to 20 milliampere, but also temperature sensors, ohm related or resistance related sensors, PT100, PT1000, and also potential free contact. So more or less any kind of sensor can be connected. Yeah, and you see here some examples. Partly we had talked about this already, like brightness sensor or humidity, but also air pressure or wind direction. I just mentioned all these sensors can be connected if you want. So it's a more powerful, more flexible solution, let's say. Yeah. Regarding software, measured values can be of course sent on the bus with different data types, like before. New here is, or new compared with or different compared with the weather unit, is that we can filter the measured values. For example, you would like to create a mean value out of the last 16 values you have measured. Allows you to filter any wrong measurement, for example. Yeah? Not possible with the weather unit, but with the weather station. Thresholds we know already from the former solution, as well as logic. Different is here any mathematical functions like comparing values. Brightness values can be compared. Arithmetic functions, plus minus is possible, so values can be added or subtracted to create any solution, or mean value can be created. So here we have some more options compared with the weather unit. The rest is more or less the same. Minimum duration for underflow and overrange of values, offset temperature for the temperature sensor if necessary. Here PT100, PT1000 can be connected for temperature measurement as well, including the option to compensate any wrong measurement due to the resistance of the wires. It can be, let me say, compensated with a 3-wire technology. It's possible here to have a very precise temperature measurement. And of course also IBUS tool connection or IBUS tool support will be available. Let's summarize the new features. Wide voltage or wide input voltage range, IBUS tool support, PT1000 connection was not available before, only PT100 in the former version. 3-wire technology can be connected for PT sensors, temperature sensors, again bigger screw terminals, and the accuracy has been improved compared with the old device. It's now on the same level like our analog input for decentralized installation, AEAS 2.1. So there's also an improvement. And finally, let's compare first of all both weather solutions we have. The weather unit with a weather sensor, one unit or one package, with the weather station and external sensors. And you see here the main differences. First of all, we have here a complete solution. Of course, here I have to buy additional sensors, but I can connect any external sensor, so I'm very flexible. Solution with shutter control unit, reserved more or less for the weather station with a powerful brightness sensor. This option to calculate mathematical functions only in the weather station. Value memory only in the weather unit. Filtering weather station only. Connecting potential free contacts only possible here, weather station. A very specific but sometimes required measurement is rain quantity. That's only possible with the weather station. Very special, but integrated in the software. Date and time coming from the GPS receiver here, or the weather sensor, only here available. Okay, regarding costs, if we compare the complete solution, including sensors, we will be, let me say, here a bit higher with the weather station for sure. But depends on the sensor you are using. Good. Finally, the analog input, which is very similar to the weather station. If you look at the device, it's not really different. It looks the same, first of all, but there are some differences, of course. Again, it's a 4-volt device to connect up to 4 analog signals. And in this case, not mainly made for any weather sensors, but made for any kind of sensors having such control signal. Again, the same as before. So remember my application at the beginning, any special temperature measurement, any humidity, any filling level you would like to monitor. Something like this can be easily done with this analog input. So again, we have different data types depending on our measurement, available filtering, thresholds, comparison, the same as before, not different compared with a weather station. Also here it's more or less the same. Duration of underflow and overrange, adjustable offset temperature, PT100 and PT1000 can be connected, and of course also support from the IBAS tool is available here. There are two main differences in the software, or there'll be three you can say. One is that we have no logic inside the analog input, not possible, only in the weather station, and we have no support of rain quantity meter. And there are also some, all the data types of weather sensors are supported directly here in the weather station, not on the analog input. So there are some changes in the application if you compare the analog input with the weather station. But it's based on the same hardware, you can say. Let's summarize here the new features compared with the former analog input. It's more or less the same like the weather station. Input voltage range, IBAS tool support, PT1000 can be connected now, also in 3-wire technology, and the bigger screw terminals. Plus calibration and higher accuracy existing also here in the analog input compared with the former version. Good. Then I would hand over to Jürgen. He would like to show you, together with the weather unit and the weather sensor, all the options you have here in the IBAS tool. Here's already a summary of the main functions, but I don't talk about this because Jürgen will explain it even better, together with some screenshots, some real pictures of the IBAS tool, and this is a real unique but very nice solution. Have a look.
Hello and welcome to the second part of this webinar. My name is Jürgen Schilder and I'm continuing this webinar with the IBAS tool. I'm going to show you how you can use this IBAS tool to simulate some weather values, like for example rain or night or 80,000 lux, and test the behavior of the parameterized shutter actuator and see if the windows are closing, for example, or the shutter drive in the safety position. So I'd like to switch off also here my camera, just a second. So now before we start with the screenshots of the IBAS tool, some details. One is very important. Before we use the thresholds later on, you have at first to enable these thresholds and assign group addresses to the thresholds. This is new. Before, all other devices, they don't need group addresses when testing with the IBAS tool. But here, in this case, it is really important to assign group addresses in the ETS, to download this application, and then later we can change, for example, here the sliders to change the thresholds, and we can save new thresholds via the IBAS tools. But be careful, when we override these thresholds, like for example wind alarm, we save this value inside the actuator, inside our weather unit, and so for example the parameterized value is now overridden. So it can happen that maybe you harm your installation when you change here to the wrong or to a not correct threshold. So this so-called IBAS tool, ABB IBAS tool, is free of charge. You can download it from our website abb.com/knx, and we will send you also in our feedback email a download link. Today we have our latest version, which is the 1910, and with this version we have the possibility to check the parameters or to simulate the weather data in our weather unit. The weather station and the analog input will come soon. So now when you install here the IBAS tool, it runs on a standard Windows, Microsoft Windows operating system. We click here on the button Connect, and then we have here our main menu. We can here connect to a single device. We can, for example, see here demo mode, and we can scan the IP network for all ABB KNX devices, and we get here a list of all supported devices we have at the moment. Now when we click on the supported devices, you can see here the overview of the DALI gateways, the light controller, shutter actuator, and new in this version we have access here to our weather unit WZIS WZIS1312. So now we go back on the main menu and then we click here on the button Connect to Device. Then we need the individual address or physical address of our weather unit. So the first step is to enable all the parameters inside the ETS and download the ETS application. Close the ETS and start here the IBAS tool. So that's why we need here this individual physical address. So for example, here in my presentation I use the address 115 to have communication to my weather unit, and I press here the button Connect, and then we have a point-to-point connection from here our IBAS tool to the weather unit with this physical individual address. Later, when you start the IBAS tool again, you will have here in the list recently used the individual address of the weather unit, including here the short name WZS, or for example of all your other devices like shutter actuators or DALI gateways. If you don't know the individual address, you can press the programming button on the weather unit and click here on the button Scan, and then you will see here in the menu Discovered Devices your individual address of the weather unit. So now we press on the button Connect, and then we have a point-to-point connection from our IBAS tool here to our weather unit. In the main menu we can see here some details of our weather unit, for example the version of the application. In our weather unit we have at the moment the version 1.0. And on the bottom we have the information of our connection, like here via USB, the number of telegrams per second. So we have here the value 6. This means we send here per second 6 telegrams from the weather unit here via KNX to our IBAS tool. So we have here also a high bus traffic. Plus the slider here to zoom in or zoom out. So now when we want to send later values to our weather unit to simulate, for example, wind alarm or rain alarm, we have to click here on the button and we have to activate a so-called configuration mode. When you click here on the button, we get another pop-up window that we now can send values to our KNX installation as we want to do it, and we click here on the button OK. So in our menu General here, we can see some general information of our weather unit. For example, the information which sensor is now connected to our weather unit, like here the new one, the 3.1, which sends also GPS time to our KNX bus, the sensor communication if it's okay, or the time signal available. Now you can see green, everything here for example is okay, or here the GPS signal is now available. And how many satellites are connected now in contact here with our weather unit. You see here the number, this is okay. And the longitude, the latitude, the sea level of this building where the weather sensor is installed, including the date and time depending on your time zone. This depends here on the setting in the ETS. For example, here I have here specified a difference between whether it is installed, this weather unit, and then he calculates and sends here automatically our time and date. So on the next page we have the 3 brightness values, right, center and left. Now what is right, what is left, what is center? It is not very difficult. When you click here on this blue info button, here on this info button, then we get here another information, a pop-up picture which shows you the sensor on this position here, this is the sensor on the bright side, this is number 3. Or on the total view, here we have the right sensor, which is this level here, the center, this is this parameterization, and the left one is here this menu. So I would like to show you all the behavior, for example, how you can simulate brightness values, or we can use the thresholds by using here the sensor on the brightness sensor on the right position. It is similar to the brightness sensor center and left, and also to, for example, wind speed meter and so on. So I start here with the brightness sensor right. In the ETS I have parameterized my 2 thresholds. Threshold number 1, that's why we see here threshold number 1 we have a green button, so this is parameterized and active. and additionally my threshold number 2 is also green, so I can now test my 2 threshold values. So let's zoom a little bit. So here on the top I can see this is the current value sent in lux from our brightness sensor right. Now this was a screenshot taken during the night, that's why we can see here only 1 lux. So in the second part we can see here our threshold number 1. You see the green button, it is activated inside the ETS. We have here the button which shows you if the current value here, the lux value, has exceeded our threshold, then it is gray, or here in this case it is lower than our lower limit of our threshold, then it becomes here red. So you can see we have here a limit of 30,000 lux, our lower limit, and at the moment the current value is 1, so we have now fallen lower than our threshold. Here in the ETS you can see a screenshot, my parameterization of my thresholds, 30,000 lux for the lower limit and 50,000 lux for the upper limit. And now what should happen when we fall lower than our lower level? Then he should send an off telegram, or for example later when we have more than 50,000 lux, then for example we send here an on telegram. So now let's simulate and test some values. So we can write here a value, so we now enter here a value, for example 60,000 lux, and confirm by pressing here the right button. And then we send a telegram to the weather unit which simulates our weather sensor outside. So normally the weather unit is listening to the sensor, to our brightness sensor right, but now when we write here a value, when we enter here value and confirm, then we disconnect internally the communication to our brightness sensor, and via the IBUS tool we send this new value 60,000 for example here to our weather unit. So the weather unit believes outside this information comes from the weather sensor. Additionally here this object or this button gets yellow, which shows you that we have overridden the sensor value here manually by entering here a value and have pressed the button confirm. So then we can test or simulate 60,000 lux and test here the behavior of our shutter control system, or changing the position, the height, or the lamellas and so on. So now let's do it. So we enter here the value 60,000, press on the button right. You will see the button here becomes yellow because we have manually overridden the sensor value, and then we can test our thresholds. Now the limit here for the upper limit in lux I set in the ETS are now 50,000. I simulated 60,000, and then now we have here overridden our upper limit, and you see here the button becomes red. So the next value I simulated here, for example 40,000 lux. So I entered here 40,000, I press the button right. So then I have a value which is between my upper limit and my lower limit. And now what happens? Nothing, because we have still in our hysteresis, and though he will not send here that we have that we are under our upper limit. At first we have to go under our lower limit, then he will react. Like here, now I change here the value and I enter 20,000. My limit here for the lower limit is 30,000, and what happens? We are falling lower, falling below our here lower limit, and then we send this information here to KNX, and then we can see the behavior of our system. So this is the principle how to simulate here, for example, the brightness value by entering here value and press the button right. So now the next step, I enter here 80,000, click here on the button right and confirm. What happens? You will see we still exceed our upper limit, because the upper limit is here now 50,000. Good, and we have another parameter in the ETS that allows us to modify here, for example, our limits or our thresholds. So my default values I have parameterized in the ETS are 30,000, and here for my upper limit 50,000. And when I enable here this parameter, I have the possibility to change here my limits or my thresholds by using here the sliders. So I take the slider and change it here, for example, to the position like here. Then I have 15,000 lux as my new threshold. And I have also to confirm it by pressing here this right button. Now when I press the right button, this value here is saved inside our weather unit. So this is very important. Not only temporary simulated, it is really written and overrides the value we have parameterized in the ETS. So and afterwards you can test here, for example, your threshold by entering here the values like I have shown you before. To stop, for example, the simulation, we have to click here on this cross, and then our weather unit is still listening to the brightness sensor outside. So when you have done all the tests and everything is okay, so click here on the button and stop the simulation. So and when you stop here the simulation, you will see we see our real value, which was during the night 1 lux, and this button here goes off. It shows that the brightness, the weather unit is still listening to the sensor outside and not here for our manual entries. Good. Here in this example, I have not activated the threshold number 2. That's why here, for example, in the sensor in the middle, you see it is gray, which shows I have only the possibility to use here my threshold number 1 in the brightness sensor here in the center. Good. The next page, you can see here the so-called twilight sensor. The twilight sensor shows here my value between 0 and 1000 lux. We have the same possibilities like before. We can use 2 thresholds. We can simulate here our brightness in lux by entering here the value and press the button wide, and here we can still also change here our thresholds for the upper limit or the lower limit for the twilight. The same like before. The day and night, we have only 2 informations. It is day, then we have the logical 1, or night, the logical 0. And you see here my status at the moment shows 0, which gives us the information it is night. And here we can do the same. We can here enter the value 1, click on the button right, and then we can simulate, for example, a day, and we will see it, the behavior in our KNX installation. The temperature, the same here. We see our current temperature outside. Nearly 2 degrees. We can see here also our thresholds for the upper limit or the lower limit, and by entering here value and press the button right, we confirm this value and we can simulate our current temperature outside. And we can also change here, for example, via the slider, our threshold, press the button right, and then we save these new thresholds in the weather unit. Day and night, also a 1-bit information. It is rain, rain or no rain. When we press here with the value 1, we have the information it is rain. This is specified to the data point type, or 0, we have no rain. At the moment here 0, it gives us the information we have no rain outside, and by entering here the value 1, we can simulate rain. Press here the button, and then we can see what happens with our roof windows, for example, or in our KNX installation. So the wind speed. We see here the real value in meter per seconds. At the moment, for example, here we have 11 meters per seconds, and here our threshold, for example, 8 meters for the upper limit and 4 meters per second for the lower limit. By entering here value, we can simulate our wind speed, which is outside, and of course we can do the same via the sliders. We can change here our 2 thresholds. So here we have, on this page, we have the information of our PT1000 temperature sensor, which can be connected. For example, here the temperature, 18 degrees. And here we have the same, the sliders to change the thresholds. Or here we can enter a value and send the value, for example, to the weather unit to simulate another temperature and see the behavior of our thresholds, if the thresholds are okay, or we have still to change it again. So here we have another nice feature, which is a kind of memory value. So inside the weather units, we have the possibility to store in a kind of buffer 4 values. For example, memory value 1, 2, 3, and 4. It depends on our parameter settings in the ETS. Maximum, we have possibility to store 4 values, and each of the value we can store the last 24 values. So let me zoom in a little bit. For example, here my memory value number 1. In the ETS I have enabled this, that yes, I want to use it. The source, for example, is my measured temperature. So I can select here, should it be my twilight or my PT100 temperature sensor, or brightness right, brightness center, or brightness left, for example. And what should be saved? My measured value, for example. yeah, or my minimum value, or my maximum value, or the average. And when the value should be written inside the memory cyclically, every hour, every 10 minutes, every 30 minutes, for example, or on a request. So on a request means I have to send the 1-bit information, and then the value is now stored inside our memory value. So here, for example, the information, the source, now here the temperature, like here in the settings in the ATS, it stores the actual value at the moment to every full hour, and I have the cycle time 60 minutes. So he gives us the information of the last 24 hours, the temperature. So for example here 2 o'clock in the midnight we have this temperature, 3 o'clock, 4 o'clock, and though I see the temperature of the last 24 hours. And here, for example, my memory value 2, I use it for the brightness, and then it's possible to see the brightness of the last 24 hours of our brightness sensor, right, left, or middle, or so on. Good, the logic. Maximum we can enable up to 4 logical gates, which are inside our weather unit. In my example, I have only enabled logic gate number 1, logical gate number 2. You see here is green, and the other gates are now gray, which means they are not activated. So each of our logical gate we can have up to 4 inputs. The first step is we have to specify the behavior of our logical gate, which can be AND or OR. Here my ETS, I parameterized your OR gate. So my input number 1, I use the internal rain value above threshold 1, together with an OR connection with my wind speed threshold number 1. Additionally, I can use my input number 3, which can be, for example, a communication object. So it can come, for example, from a time switch, or from a presence detector in a room. It can be also a telegram which is sent via the KNX to the weather unit. So the result, I have the possibility to invert or to negate the result, and when the result should be sent cyclically or when it changes automatically. So, or here, for example, I can also test this logical gate. So I go back to my page rain, say yes, it is rain, and we have wind. And then we can see yes, the result here is true. And so we can also test here also our logical gate. So, and on the last page, we can find some information about the software or firmware inside our weather sensor. For example, the version of the firmware which is at the moment inside our weather sensor. We have the possibility to update this firmware via the IBUS tool. Now, for example, when we launch a new firmware, maybe bug fixing or additional feature, then we can open here a file, our update file, which will be available on our website, and then we can download this new firmware via the IBUS tool into our weather sensor. So we have not to replace the weather sensor, which is installed outside, maybe on the roof, on the top of your building. But it can last, depending on the size of the update, up to 40 minutes, this update. Good, so far a small overview of this IBUS tool, what you can do, how you can simulate weather values like rain or temperature, for example, how is it possible to change the thresholds, but be careful when you change the thresholds because they are really saved in our weather unit and overrides our parameterized value which we have done via the ETS.
Maybe finally a short information about our next webinar coming in 4 weeks, the 18th of March, dealing with security again, but not related to our KNX devices, but to the basics of security in buildings. So what is basics? What is security in buildings at all? The definitions, standards and guidelines is a big topic. The wording behind, and of course also a small overview of the conventional security products. You need also as components if you would like to integrate it in a complete solution together with KNX, of course. Thank you for participating and see you next time. You will get, of course, an invitation on time. Thank you and bye-bye. Ciao. Goodbye.